So again, with these ones, this is practice. So factor these on your own and then come back and check your answers. So make sure that you're practicing these on your own. So when I'm factoring these ones, I'm going to use essentially a 4-step method, or get the split of the 11x. So I'm going to write my 4x squared here, minus 3 here. My cross diagonal here is negative 12x squared. So I need to split up my 11 into a positive 12x and a negative x. So that's going to add to the positive 11 and be able to give me my cross diagonal product that equals negative 12x squared. I find my horizontal greatest common factor here. Okay, so I get 4x. This one's going to be negative 1. Vertically it's going to be x, and then it's going to be plus 3. Okay, so again, all the area parts add up. Okay, if you multiply this out, the area parts all add up, and then we end up with our factor parts, length and width. Okay, so same thing here. We're gonna, first of all, we should always check for greatest common factor. There's no greatest common factor. And to figure out how to split up that 6, we're going to use that cross diagonal product of negative 72x squared. So the factors of 72 are going to be, well, we have 8 times 9, we have 6 times 12. Well, 6 times 12 will have a difference of 12. So we're going to use negative 12, positive 6. Okay, so that splits the middle and allows us to then decompose this into its length and width. So we get 4x. The horizontal here is going to be, the common factor is 3. So it's going to be 4x plus 3. Here we have a common factor of 2x. And the common factor here is going to be negative 3. Okay, so negative 12 and negative 9 share a common factor of negative 3. So there's our length and width. For this one here, we need to make sure that we factor the greatest common factor out first. So there's a common factor of just x. Okay, so then now we can apply this into our grid model. So our diagonal product again is negative 72x squared. Now we're looking for a sum of negative 11. Okay, so when we look at negative 72, the difference being 11, okay, we could try, factors of 72 are going to be like 18 and 4. Okay, 18 and 4 don't work. The next factor will be, 12 and 6. That doesn't work. It looks like we don't have any numbers that have a difference of 11 and multiplied it by 72. Okay, so we've tried our factors of 72. Okay, we could try 24 and 3. Again, that's just too far apart. Okay, and there essentially are no factors that exist. So at this point, this is done. Okay, we cannot factor this anymore. So this piece here we call prime because it's not, we cannot factor it anymore. So the last one here, again, we look for our greatest common factor. Now we have this x squared, xy, y squared. So this pattern is a quadratic pattern, so we should be able to fit it into our model. So we're going to put it into our x squared here, negative 5y squared. Okay, our cross diagonal product is negative 50 x squared y squared. Okay, well, I can split up 23xy to multiply to x squared y squared if I have xy here and xy here. So we're looking for two numbers that multiply to 50 have a difference of 23. That's going to be positive 25xy and negative 2xy. Okay, so then our greatest common factor along here is going to be 5x. Okay, here we have a common factor of y as well, so we have to make sure that we include that. So there's where our y shows up. Again, note there's a common factor of y here and here. Vertically, there's a common factor of 2. And vertically here, there's a common factor of negative. Oh, sorry, it's going to be positive, isn't it? Because the negative was common this way, so this is going to be positive 5y. Okay, just double checking, yeah, everything multiplies out to the right coefficients and the right variable parts. So there it is. There's my factored form. It's going to be 2x plus 5y times 5x minus y.